Alrighty, here we go with the last part of stoichiometry, at least for now. The last section in your chapter 12 is about limiting reagents. It's another word for reactant, and percent yield. A lot of you are expressing concerns that you're not understanding the brownie packet, so hang on, we'll get to that and finish that up, but we have to talk about this first, okay? So they start out with an example of a carpenter trying to build tables. He's got 2 tabletops and 7 legs. You know, if you want to make a 4-legged table, he could only make 1. He wouldn't have enough legs to complete the second one. It's kind of the same thing when you're cooking also. Sometimes you want to make a recipe, but you need 2 eggs and you only have 1, or 4 eggs and you only have 2, whatever the case. And so sometimes certain ingredients, if you will, limit how much you can make. This is a huge important concept for chemists because they're usually in the process of making stuff, and so they need to know how much of each ingredient they need, reactants, in order to make the desired amount of product. The other thing that comes into play is how much you actually get from your quote-unquote recipe. So limiting reagent is the one that you have not always a smaller amount, but you have less than you need to do the reaction. So it's going to limit how much product you can make. And then the excess reagent, or XS, my little shorthand here, is the one that you have plenty of, lots and lots of, doesn't limit your amount of product based on your recipe, which of course for chemists is the balanced equation. So let's go back to brownies. I hope you guys give that recipe a try. It actually turns out pretty good. I had to modify it from when I first got it, but they were sure tasty. Let's say your brownie recipe calls for 2 sticks of butter and 4 eggs, like ours. You go into your kitchen, you've got 1 stick of butter in the fridge and 12 eggs. Holy cow. So knowing the proportions, 2 of these to 4 of these, from the recipe, you can only make half a recipe based on the butter. You could triple the recipe based on the eggs. Okay, but the butter's going to limit you. I answered the question already, because the recipe calls for twice as much as what you have. Okay, and of course the eggs are going to be left over, excess, because you won't use them all, especially with only 1 stick of butter. So going back to our ammonia production recipe, 1 nitrogen, 3 hydrogens make 2 ammonia molecules. Okay. So what's in your cupboard? In this example from your textbook, there's 2 nitrogens there, which is twice as much as the recipe calls for. There's 3 hydrogens, which is exactly what the recipe calls for. How much product could you make? Well, hopefully, after the reaction, you can see there's going to be a nitrogen molecule left over. There won't be any hydrogens left over, and you will only be able to make 2 ammonias. Going back to our definition, sorry, the limiting reagent then is the hydrogen. If we had more hydrogen, we could make more ammonia because there's more nitrogen available. Right, the other thing that's really important is percent yield. Percent yield is how we measure how efficient the reaction is, how much of it you have to actually do to get the desired amount. Most of the time, when you cook, some of you have probably experienced this, if you're making chocolate chip cookies, recipes, I don't know how they do it, they always call for more cookies than you can actually get. Okay, so if you're like me and don't mind a little salmonella now and then, and you eat your raw cookie dough, maybe you only get 43. And of course, in reality, some of the stuff's left on the bowl, on the spoon. It doesn't all get out onto the baking sheet. So if you get 43 out of 60, probably, most of you can do the math on that one, it's about a 72% yield. And that's still, for chemistry, that's still a really high percent yield. Lots of reactions are less than 50% efficient. It's really crazy. And going back to that, that means you need to make a lot more. You need to have a lot more reactants on hand and try to make a lot more to get what you really want. So theoretical yield is what you should get based on the amount of reactants you have available. The actual yield is what you really get, kind of like our cookies. You should get 60, you only got 43. And when we do percent yield, this is a super important calculation. You take what you actually got divided by what the recipe says you should get, multiply by 100, of course, and that'll give you percent yield. No chemical reaction is 100% efficient. None of them. That's one of the few absolutes I can tell you in chemistry. This is a hilarious old look at Alka-Seltzer. There's another lab that I like to do, finding the percent yield of carbon dioxide from the Alka-Seltzer reaction. I'll put this clip, it's really fun. Show it to your parents. They'll probably remember these commercials. But Alka-Seltzer is supposed to help with heartburn, which of course is acid indigestion. The tablets are composed of sodium hydrogen carbonate, which of course you know is baking soda. They also have this horrible looking thing, that's citric acid. This is the citrate ion, and of course acids are the cations, or hydrogen. And there's a certain amount of carbon dioxide that should come out of this reaction, and sodium citrate remains in solution in the water. This is similar to what we did, the baking soda and vinegar. I think we did vinegar in our types of reaction lab. So when you balance this equation, you're going to need 3 times as much baking soda, 3 times as many particles, not mass or volume, of baking soda as you have citric acid, and from those 3 baking soda molecules, you'll be able to make 3 CO2 molecules. And then from there, there's a whole series of calculations, but given our circumstances this year and AP tests and such, I think I'm going to skip this one, even though I've already videotaped it. Maybe I'll do that the last week of school. I don't know. Anyway, Plop Plop Fizz Fizz. It was the jingle for the Alka-Seltzer commercials, and it's a fun lab. You'd also get 3 waters. Sorry about that. I forgot that. And that's it. Stoichiometry is done. Yay.